We're building these incredibly powerful AIs to solve some of the world's biggest problems. But what happens when we give one a problem that's just impossible to solve? You'd think it would just throw up its hands and say, I don't know. But the reality is actually way, way stranger. And it kind of exposes a fundamental crock in how these super smart models think. Let's dive in. Okay, just look at this. On the left, a pretty basic model gets an unsolvable question. What is the value of A? And it does the right thing. It asks for more context. But on the right, a state-of-the-art reasoning model gets the exact same question. Its response? It takes almost 5 minutes to spit out over 8,000 tokens of absolute nonsense. How does the supposedly smarter AI get it so wrong? That's the mystery we're going to unpack. So this bizarre behavior actually has a name. Researchers are calling it MIP overthinking. It's a newly identified flaw, and it's pretty fascinating. So in this first part, let's just open the case file and figure out what exactly we're dealing with. So what is MIP overthinking? Well, the MIP part stands for missing premise. It's what happens when an AI gets a question that's missing a key piece of information. Something it absolutely needs to get a logical answer. But instead of just flagging the broken question, the model gets stuck and just goes on, generating these super long, rambling, and totally useless responses. Now, it's really important to get this straight. This isn't just overthinking in general. That's like, writing a 10-page essay to solve 2 plus 2. MIP overthinking is different. It's not about using too much brain power on a simple but solvable problem. It's about getting completely trapped in a loop of bad logic because the problem itself is fundamentally broken. All right, so how did researchers even diagnose this thing? Well, they put two kinds of models under the microscope: the heavy-hitting reasoning models and the more basic non-reasoning models. And the key to this whole investigation is seeing how differently they handle the exact same unsolvable questions. Yep, the whole case really comes down to this one comparison. When researchers fed both types of models the same broken questions, a pattern emerged that was, well, it was pretty shocking, actually. Let's take a look at the data. And here it is, the first big piece of evidence. This chart shows you the average response length when these models get an unsolvable question. The non-reasoning models on the left, they keep it short and sweet, around 200 tokens. But then look at the reasoning models on the right. Their response length just explodes. We're talking an average of over 3,000 tokens of just wasted effort. To really put that into perspective, these advanced models are generating answers that are 2 to 4 times longer for questions that have no solution than they do for normal ones. Just think about that for a second. They are literally working harder on the problems that are impossible to solve. So, okay, they're thinking longer, they're writing more. The obvious question is, does it help? Is all that extra computational muscle actually leading them to the right conclusion, which is realizing the question is flawed in the first place? The evidence says absolutely not. In fact, it's the exact opposite. This chart shows what's called the abstain rate, basically how often the AI correctly says, hey, this question is unsolvable. The simpler, non-reasoning models get it right almost half the time. But the advanced reasoning models, after all that extra thinking, they only get it right a measly 16% of the time. And that right there is the central paradox of this whole thing. The models that are specifically designed for deeper reasoning, the ones spending way more time and energy on the problem, actually perform worse. They think more, and because of that, they fail more. This finding is a huge deal because it completely turns a core idea in AI on its head, something called the test time scaling law. The basic idea of that law is simple. The more time you let a model think, the better its answers should get. Well, MIP overthinking shows us that's not always true. Sometimes more thinking just digs a deeper hole. So we've seen the evidence of what is happening. Now let's try to get inside the AI's head a little bit to understand why. What does it actually look like when one of these models gets trapped in a thought loop? Okay, so what you're looking at here is basically the internal monologue, the step-by-step reasoning of a model trying to solve an unsolvable problem. I mean, you can see from all the colors, it's just a tangled mess, right? But within all this chaos, researchers found 5 distinct repeating patterns of really ineffective thinking. Let's break this loop down. First, it revisits the question. The model just reads the prompt again and again. Then visit knowledge. It pulls up stuff that's kind of related, but not actually helpful. Third, propose assumption. It just starts guessing to fill in the blanks. Fourth, self-doubt. It literally starts questioning its own logic. And finally, it'll pause and check, where it stops to review all the unhelpful stuff it just did. And then the whole cycle just starts right back over again.
And that's the vicious cycle that makes the response length just balloon. The model isn't actually making any progress, it's just spinning its wheels, generating thousands of tokens of pure, useless, redundant thought.
Okay, so we've seen what happens, and we've got a good idea of why it happens. So what's the final verdict here? What does all of this tell us about a really critical gap in the way our most advanced AIs, well, think?
This really brings us to the most important question of all. Is the AI just totally clueless from the start? Or does it have some inkling that something's wrong and it just fails to act on it? And honestly, this is the single most mind-blowing finding from the entire investigation. The data shows that in almost every single case, the reasoning models do suspect a piece of information is missing, and they suspect it pretty early on. Their in-process suspicion rate is nearly 100%, so they know something is wrong. But they just can't bring themselves to act on that knowledge, and they get stuck in the loop instead. This quote from the research paper just says it all perfectly. The models have the ability to figure out that the question isn't solvable, but they don't dare to just stop. It's not a failure of detection, it's a failure of confidence. It's a deep lack of what we would call critical thinking. So why does this even happen? Well, the leading theory is that we've kind of trained them this way. Our current models get big rewards for showing their work, for producing these long, detailed, step-by-step answers. What they don't get rewarded for is that crucial skill of stopping, looking at a bad question, and just refusing to answer. And this leaves us with the big final question for the future of AI, doesn't it? We've become experts at teaching an AI how to follow a bunch of steps to find an answer. But the next great challenge is crystal clear. How do we teach an AI the wisdom to know when to stop thinking and instead start questioning the question itself?